My name is Jens Hagen from the Breda University of Applied Sciences game program, and for my Bachelor graduation project I work with the research and development team on the creation of digital humans. Breda University of Applied Sciences is working on the FIBE project with the goal of developing a realistic digital human for training purposes. To develop highly detailed digital humans, we use a process called photogrammetry, by taking multiple synchronized photos of a person and then create a 3D model that can be animated. This process works well for exposed areas, but hidden areas like the inner mouth cavity, it is not possible without specialized equipment. And even then, a 3D artist is needed to manually model it. For this project, it was requested that I investigate how we could use deep learning to support the reconstruction of realistic teeth and incorporate it into the avatar pipeline to reduce the need to manually recreate it. During my research, I found the 2016 paper Model-Based Teeth Reconstruction, outlining the workflow of 3D teeth generation based on pictures. I followed their approach, experimented and adapted it to the current process. We start with a frontal photo of a person with exposed teeth. One can then select a border around the general mouth area, which will automatically be fitted to the correct width and height. In the cropped image, the centers of the 4 front teeth are selected using a tool I developed, which can then be synchronized with a template. This information is used to create offsets that later can be used to synchronize the probability maps. The selected teeth area is then put through a neural network that has been trained to recognize the edges of teeth with a few different classifications. The red lines are the boundaries between the teeth. The green lines are the boundaries between the teeth and the gum. And finally, the blue lines are the teeth and lip boundaries. To find these boundaries, I looked into CaseNet, a neural network that has been trained to find edges in complex scenes based on ResNet 101. ResNet stands for Residual Neural Networks, and they allow some layers to be skipped, like shortcuts, which effectively simplifies the network and improves the learning process. I use a ResNet 50 network and replicated the CaseNet functionality. This is possible with a lower requirement of different classes of edges. I created and developed our own dataset and manually labeled the data corresponding ground truths. After we get a probability map or prediction, it goes through a cleanup and smoothing process. For the next step of the process, we create a 3D model that serves as a template and created a support system that allows for parameterizing 3D models of different teeth, according to position, rotation, scale and shape. These shapes can cover different possible teeth variations in terms of length and width. Starting from a standard position, a 3D modeling software, in our case Autodesk Maya, the outline of the generated teeth is determined. This outline is compared with the prediction provided by the ResNet, and based on the differences, a new set of parametric values are then calculated. This process is repeated until an optimal parameter set for all teeth is reached. Such system is fully integrated with the Photogrammetry Studio, allowing the automatic generation of 3D models creating a realistic replica of the person's teeth. By using a 3D modeling software as platform, it is possible to provide a great base for a 3D artist to further edit or customize the teeth.